Welcome back, guys. Part 2 of section 10-2 angles of rotation. Two more concepts are left in this section, guys. One of them is the reference angle. The reference angle of an angle theta in the standard position. So take this angle theta in the standard position. This is the initial side and this is the terminal side of that angle. The reference angle of theta is the angle formed by the terminal side this one, excuse me, and the closest x-axis, this direction, guys. So this is the reference angle theta dash. This shaded one is the reference angle. Example number 3, find the measure of the reference angle for each given angle. The first one, guys, theta equals 135 degrees. Our job is to find the reference angle of angle theta. Guys, it's very useful to visualize the situation. So this is our angle. We start from the initial side and this is the direction of rotation because the angle is a positive one. So this is the terminal side. Where is the reference angle? The reference angle is formed by the terminal side and the closest x-axis, this one. Remember, guys, if you start from 0, the opposite way is 180 degrees. So this one, theta dash, is the reference angle. How do we get the measure of the reference angle? By subtracting 180 minus 135 is equal to 45 degrees. Another part, theta equals negative 105. So this is the initial side and this is the direction of rotation, and this side is the terminal side of this angle. Remember, guys, the reference angle is formed by the terminal side of the angle and the x-axis, the closest direction of x-axis. So this is our reference angle theta dash in this situation. Guys, don't consider the negative sign in your calculation. The negative sign only refers to the direction, but the measure of the angle itself is 105. So to calculate the reference angle, the measure of the reference angle, it's going to be if you start from 0, so the opposite way is 180. So it's going to be 180 minus 105 equals 75 degrees. One last angle. Theta equals 325. So this is the initial side and this is 0. The rotation is this way, counterclockwise, because the angle is positive. So this is our angle and this one is going to be the terminal side. The reference angle is the angle formed by the terminal side and the closest x-axis. So this is our reference angle theta dash. We need to figure out the measure of this angle. Guys, if you continue this complete round, at 0 it's one complete round, so it's 360 at the same time. So to get the measure of this angle, you subtract 360 minus 325 is equal to 35 degrees. The measure of the reference angle of theta equals 325 equals 35 degrees. One more concept, guys. How to find the 6 trigonometric ratios or the 6 trigonometric functions of an angle in the standard position. So we start with an angle theta in the standard position. So this is the initial side and this one is the terminal side, and we given one point on the terminal side. Take any point P, its coordinates are x comma y, and we need to find the 6 trigonometric ratios. Guys, if we drop a perpendicular line from this point to the x-axis, the length of this distance is y, the y coordinate, and the distance from the origin point to this perpendicular line is x, the x coordinate. So we have created a right triangle in order to apply the right triangle trigonometry. So guys, we just need to find the hypotenuse. Let the hypotenuse of this triangle be r. To find the length of this r, we need to apply the Pythagorean theorem. If you apply the Pythagorean theorem, r equals the square root of x squared, the horizontal distance, plus y squared, the vertical distance. Now guys, we can apply the 6 trigonometric ratios. Everybody knows that sine theta equals opposite over adjacent. The opposite is y and opposite over hypotenuse. The opposite is y and the hypotenuse is r. So sine theta equals y over r. This is the first formula to find the 6 trigonometric ratio for an angle in the standard position. The second trigonometric ratio, guys, is cosine theta. From your previous study in section 10-1, you know that cosine theta equals adjacent over hypotenuse. The adjacent is x and the hypotenuse is r, so cosine theta equals x over r. Tan theta equals opposite over adjacent. The opposite is y, the adjacent is x, so tan theta equals y over x. If you need the other three trigonometric ratios, you can just find the reciprocal of each one of them in order to get the cosecant and the secant and the cotangent ratio. Example number 4, guys. Take the point P, -6 and 9. This is a point on a terminal side of angle theta. So guys, this is the initial side and the red one is the terminal side, and this is the angle theta. The direction is this way, counterclockwise, and we have a point on the terminal side. Our mission is to find the exact value of the 6 trigonometric functions of theta. Guys, let's get started with creating a right triangle. If we drop a perpendicular line from the point to the x-axis, this distance is the y coordinate, y equals 9, and the horizontal distance, guys, is exactly the absolute value of the x coordinate, because distance cannot be negative. So the distance from here to here is 6 units, but the coordinate itself is -6. So this is 6 units, but the coordinate x is -6. So guys, now we can name this hypotenuse r. And step number 1, we need to apply the Pythagorean theorem in order to get the length of the hypotenuse r. So according to the formula, r equals square root of x squared plus y squared. If you substitute that, guys, x squared, the square of -6 is 36, plus the square of 9 is going to be 81. If you simplify that, it's going to be 3 square root of 13. Now let's get started to find sine theta, cosine theta, and tan theta. Sine theta formula is equal to y over x. The y coordinate is 9, and y over r, not y over x. Y over r. Sine theta equals y over r. So it's 9 over r equals 3 square root of 13. 3 times the square root of 13. Guys, if you put that in the calculator gonna rationalize the answer, and the answer in the rational form gonna be 3 times the square root of 13 over 13. The trigonometric function cosine. Cosine theta equals x over r. The x coordinate, guys, of this point is -6, and r is 3 times square root of 13. If you rationalize this answer in the calculator, it's going to be -2 square root of 13 over 13. Let's find the third trigonometric function, tan theta. Tangent theta equals it's y over x. The y coordinate is 9, and the x coordinate is negative 6. If you simplify that, guys, it's going to be negative 3 over 2. Negative 3 over 2. So, guys, we have found the three basic trigonometric ratios. No need to apply any more formulas to get the other reciprocal. So, guys, you can just flip this one to get the cosecant. The cosecant theta is equal to the reciprocal of sine, and if you flip this number and put it in the calculator, it's going to be square root of 13 over 3. Secant theta is the reciprocal of cosine theta, and if you rationalize this, it's going to be negative square root of 13 over 2. And finally, guys, tangent theta, cotangent theta, the reciprocal of tangent is cotangent theta. Cotangent theta is the reciprocal of negative 3 over 2 is equal to negative 2 over 3. So, guys, we have found the exact value of the 6 trigonometric functions of an angle in the standard form. Practice well.